Good morning or afternoon whenever you're watching this. This is Mrs. Phelps going over the Chapter 7 review for the final. So we've got simplifying rational expressions, adding them together, multiplying, and then solving a rational expression. And then the last two problems, the last problem, number 6, is looking at rational functions and determining if they have vertical asymptotes and or points of discontinuity. So to start, for problem number 1, it says simplify completely. We want to add these two rational expressions together. So we need to find a least common denominator. To find the least common denominator of these two binomials, that's going to be x plus 4 times x minus 1. And we don't need to multiply them out. In fact, it's better that you don't multiply them out because then you can see what you need to multiply the first term by to get that denominator, what you need to multiply the second term by to get that denominator as well. So the first term we need to multiply by, we've already got x plus 4, so we need to multiply by x minus 1 over x minus 1. And then the second term we want to multiply by x plus 4 over x plus 4. So that's 3x over x plus 4 times, so x minus 1 over x minus 1 plus 5 over x minus 1 times, and then x plus 4 over x plus 4. And we need to distribute. So that's 3x times x, 3x squared, minus 3x over, and then this is x plus 4 times x minus 1. This is also x plus 4 times x minus 1. So I'm just going to make it one denominator now, x plus 4, x minus 1. And then plus, we've got 5x plus 20. So this can be simplified to 3x squared plus 2x plus 20. And that's all over x plus 4 times x minus 1. And then for the second problem, we have a quadratic and a binomial. So to find the least common denominator, we first want to see what this factors to, and more than likely this binomial is going to be one of the factors, or one of the binomials that works out for the quadratic when we factor it. So let's check x squared minus x minus 6. We need two numbers that multiply to negative 6, add to negative 1. That's x minus 3, x plus 2. Double check it. Negative 3x plus 2x. Yes, that's negative 1x. Negative 3 times positive 2 is negative 6. So the least common denominator is going to be x minus 3 times x plus 2. We've already got that for this term. And then for the second term, to get this denominator, we just need to multiply by x minus 3 over x minus 3. So first term, 2 over x squared minus x minus 6, it's already good, plus the second term, 1 over x plus 2, multiply by x minus 3 over x minus 3. And again, we said this is the same for both. I should have written this as x plus 2, x minus 3, so we can see they're the same. But we can now distribute. That's 2 plus 1x minus 3 all over x plus 2 times x minus 3. And combine like terms. This is x minus 1 over x plus 2 times x minus 3. And that's added together. So this is adding two rational expressions. Number 3 and 4 are multiplying rational expressions. When you multiply rational expressions, it's just like multiplying fractions. You multiply across. So we could multiply across, but you'd get large numbers in the process. So instead, you can look to see if there's anything that can be simplified first. So if we can simplify anything here, or you can even simplify this way. It's not cross-multiplying. Cross-multiplying is if you have two fractions set equal to each other. It's not cross-multiplying. Multiplying across means that you can look to see if this numerator and this denominator have anything in common. The only reason you can do that is because this is multiplication. So it's really just negative 6xy times 14z cubed over 28z times 18x squared. So it's really all just one term. So that's why you can cancel stuff out. So if we look to see what can be canceled, you can just start crossing stuff off, but I'm going to put things in order of the terms so we can see what goes together. It's negative 6 times 14 times x times y times z cubed all over 28 times 18 times x squared. There's no y's in the denominator, times z. So z cubed and z cancel out to make just z squared in the numerator. Y is by itself, and then x over x squared. You can cancel out the x from the numerator. We're left with 1x in the denominator. And then you could simplify the 14 and the 18, the 6 and the 28, but 14, we know 14 goes into 28, so that might be a little bit easier to simplify. 14 goes into 28 2 times, so that's 2 in the denominator, just a 1 in the numerator. And then 6 goes into 18 3 times, but this is negative, so I'm just going to keep the negative in the numerator. It's negative 1, and then denominator would be positive 3. So see what's left over. This is negative 1 times y times z squared all over 2 times 3 times x. That's 6x. And this is simplified. Be careful when you're entering these on Schoology. Make sure you follow exactly as it says. So the format will be shown like parentheses, negative y, z squared, and then you have to close the parentheses, then divide, do new parentheses. Here we don't need new parentheses because it's just, that's not true. We do need parentheses actually. We need parentheses because we're dividing this whole quantity. And then the other thing with this is make sure when you simplify that you have no negative exponents. So this problem didn't have any negative exponents in the process, but if there was a negative exponent, then you want to make sure that you flip it either to the numerator or denominator. Okay, so number 4 is multiplying. We've got a quadratic over another one, quadratic over another one. So the first thing to do when we see quadratic is to factor it. We want to see if there's going to be anything that can be canceled out. So if we factor x squared plus 3x minus 10, that is x plus 5 times x minus 2. This is x plus, and be careful here, it's common to think, oh, it's just going to be 5 and 1, but that's not true. They need to multiply to 6, add to 5. So x plus 3, x plus 2. This is going to be x plus 3 times x plus 5, and x plus 2 times x plus 2, or x plus 2 squared. So we've got x plus 5, x minus 2, and then over x plus 3, x plus 5. And again, this is multiplication, so you can just put all of the terms together, x plus 3, x plus 2, over x plus 2, x plus 2. So now we can look to see what cancels out. Numerator and denominator both have x plus 5, they both have x plus 2, and they both have x plus 3. So all that is left over is x minus 2 over x plus 2. This can't be simplified anymore. So that's the end of that problem. For number 5, it's solving a rational equation. So this is an equation because we've got something on both sides of the equal sign. So it's just like these first problems, but we actually need to solve for the value of x. So to do this, because we've got fractions, we want to come up with the least common denominator. So the least common denominator of 6, x minus 3, and 1. So the least common denominator is 6 times x minus 3, or you can write that as 6x minus 18. I like to just keep it as 6 times x minus 3 so that you can see more easily what you need to multiply each term by to get that denominator. So we have 17 over 6. To get 6 times x minus 3 as the denominator, we've already got the 6, so we just need to multiply by x minus 3 over x minus 3. And then minus 5 over x minus 3. To get this denominator, we need to multiply by 6. So 6 over 6 equals 2 over 1 times, to get this denominator, we have to multiply by the whole quantity. 6 times x minus 3 over 6 times x minus 3. And if you want to rewrite this a little bit neater, you can, but the idea here is if we get the same denominator for all the terms, 6 times x minus 3, these can all be canceled out. The denominators can all be canceled out. It's the same thing as if you had said 6x minus 3, I'm gonna multiply by that on both sides. You can multiply on both sides of an equation is allowed, or you could divide on both sides of the equation. But if we multiplied, this would cancel with that, it would also cancel with that, and it would also cancel with that one. Anyway, so when we cancel out all the denominators, that's 17 times x minus 3 minus 5 times 6 equals 2 times 6 times x minus 3, or just 12. So 17x minus 51 minus 30 equals 12x minus 36. Bring x over, this is 5x. We need to add 81 to the right side. Negative 36 plus 81 is 45. So x comes out to 9. And then because this is an equation, we can check the answer. Not a bad idea. Plug x back in. So 17 over 6 minus 5 over 9 minus 3 equals 2. That's 17 over 6 minus 5 over 6. 17 over 6 minus 5 over 6 is 12 over 6. Yes, 12 over 6 is equal to 2, so it's good.